Okay, one thing I'll just let everybody know, just to head off the meeting, to start off the meeting is, let me just point out that we do record these meetings and we do share them. So if anybody prefers to not be recorded, then you can watch the recording at a later time. But just fair warning on that. We don't share them very publicly yet, but it's always possible it's going to be posted more publicly as well. And you also get the link for the document if people want to look. Here is the notes from the last couple of stateless calls that we've had. This is we've been holding them the last couple of months on a monthly basis. We decided at the most recent meeting that I think there's been some kind of good progress, especially by Piper on putting together a little bit more of structured thinking around possible, course of the work to be done and the kind of team structures and possibly even the kind of funding. And we thought it would be helpful to have a focused discussion on that. So whereas in regular meetings, we'll sort of hit a number of different topics. In this one, originally, I think we set it up and it was a little bit more of Piper's guided discussion. Piper, did you put slides together as well?
I don't. I think I'm gonna see what using my previous slides looks like, but it might be really sloppy, and I might bail on it halfway through. We'll see how it goes.
All right, good. Set the expectations low. Now you can over deliver. And then I think also Paul has put in a request for 10 minutes. About feedback on some design goals for Regenesis specifically. I think the order that it's written in the call notes, agenda for this meeting, I think that's a good order that we can do the Paul discussion at the end. Because at that point, all of us, we have a million things we look at day to day, and listening to Piper's description of his thought process is going to get everybody to context switch in and frame in all of the relevant topics around statelessness. And so that'll be helpful for Paul because Genesis is a specific portion of it potentially.
Oh, because it's going into my headphone. Oh, you want to hear what he's saying?
You can skip. What's up, Jason? We can hear you.
Piper, if the conversation's good and we're making good progress, then we can skip my part, Piper.
Cool. I'd like to sort of try to time box things, but we can kind of play that by ear. So Robert, if you'll interrupt us at 9 or in 24 minutes, just to, it doesn't mean we have to stop then necessarily, but that would be.
Time check. Yep.
Cool. Grabbing a PDF copy of this thing. Hold on so that I can show the screen. Here we are. I don't know how to present with this. I'm just going to go back to the web app. All right. Let's see if I'm able to share. It looks like I can. There's a browser tab. Cool. Can you guys see this?
Yep, looks great.
Cool. I'm not gonna formally give this talk because generally when I give these things, I'm kind of targeting a pretty very wide range of knowledge, and I think that the knowledge base in this group is adequate that I get to skip over a lot of stuff. Let's see. So the core premise behind what I'm kind of talking about here is that we have this roadmap right now, and the roadmap is basically make witnesses small enough. Sorry, I'm just going to get us onto a less distracting slide. Make witnesses small enough, put them into the core protocol in some way, distribute them in some way. Voila, we have stateless block execution. What I've come to realize, or that it wasn't just obviously clear to me, is that such a client that does this kind of stateless block execution in the totally minimal way that we're looking at doing it is only useful in the context of ETH2. I do not believe that anybody else would use one of these clients. And the reason that I say this is that because you will not be able to broadcast transactions because it won't be able to be part of transaction gossip. It will not be able to serve any of the JSON RPC APIs or expose any of the like standard user-facing functionality. It'll literally just be able to verify state roots as the blocks come in. There's value in that in ETH2, but it isn't a very compelling piece of software in my opinion. And if the only value is in ETH2, it's hard for me to imagine the work actually getting put in to make these things until that is like here. So that's one side of just like, I don't think the thing is highly useful other than for ETH2 infrastructure.
Specifically, you mean value in ETH2 in that consensus entities, consensus participants can run with fewer resources. And so maybe you have a more democratized consensus layer.
Yes,
Yeah?
and even that,
Okay.
yeah, and I think even that piece, there's a couple of question marks around it in terms of exactly what that needs to look like. But yes, that what you said.
Okay.
The other piece is that there is protocol work, and we are doing that protocol work right now. That's great. The binary tree, the Merkle, the code Merkleization. There's things coming down the line from ETH2 research that might change some of that stuff, but ultimately we're doing the work to make witnesses smaller. And the extra work for getting getting an echo back from somebody.
Can everyone mute?
Cool. Let's see, still there? Excellent. Yep, still there. All right, so the extra work beyond the protocol to actually get the clients working is the part that I'm not sure is actually going to happen, at least not until ETH2 is right here, because there's the piece in the actual consensus protocol that needs to be done, but then there's going to be a bunch of extra work that also needs to be done kind of at the networking layer and just at the like client infrastructure layer itself. There's going to need to be some sort of new gossip network that these kind of ETH2 stateless infrastructure clients can get access to new blocks because they can't be part of the ETH protocol. And somebody's going to have to be producing the witnesses. And so like, it's really hard for me to imagine this path being highly successful. And even if it is successful, it's not that interesting. It doesn't get, I mean, yes, it's cool that we get this ETH2 infrastructure, but it isn't really that compelling for the amount of work that's going to go into it. Questions so far about that? This is sort of my, like, this is where I'm going to go next, is kind of talking about
slight counterpoint there. Like, I mean, that's like saying, oh, what's so compelling about ETH compared to a centralized database, right? So decentralization is a feature as well, right?
Fair.
Just to be clear.
Totally fair. And I'm not trying to like discount the value in ETH2. It's hard for me to imagine us actually getting there until ETH2 is actually basically here. So it's interesting, but how about this? It's not compelling for me. Like that's a statement I can say without qualifying it. It's cool to have, but I'm not.
Right, and I mean, I think like we agree that most likely the merge will actually happen before statelessness is all done and dusted.
Right.
So we probably will have ETH2 by the time this is implemented.
Sure. And if we just deliver that, great. And the real part of this is that like a lot of the work that needs to be done there is like completely out of the control of everybody but existing client devs. And so it really becomes up to them to decide whether or not they want to prioritize doing that work. And I'm not suggesting that we change any of that. So I lead with that, which is that I'm not saying this roadmap is wrong. I'm just pointing out some things I've noticed about it. And I'm not suggesting that we shouldn't do the things that we've already set out to do. What I want to do is I want to add.
Okay, I wanted to kind of get through this, your conclusion through my prism of, I think, yeah, I agree with what you said, and I want to explain why this actually happened, why we actually came to this problem. From my point of view, is because there was a blind spot in our original discussions about stateless Ethereum. I think it was my blind spot, and I think everybody else's as well. So the hope was that the stateless, stateless client would be able to participate in basically in that gossip network. It will be able to propagate everything. But I think we've forgotten about, it will be able to do everything except for, it will not be able to participate in a transaction pool. So it will be able to propagate blocks because the witnesses will allow it to verify it. It will be able to do blocks, headers, and stuff like this, but it won't be able to participate in the transaction pool fully. And that's, I think this is the main blind spot.
Are you assuming that transactions don't come with witnesses?
Yes, if we think specifically about the pure stateless client, which is not Regenesis client, which is kind of halfway between, then yes, in the pure stateless mode, the transactions come without witnesses, and the stateless client might not have and probably won't always have the state to be able to correctly pass it through. However, in the Regenesis mode, it might be the case that it might be able to do so. So what I'm saying
I think that's a mistake. So I think the stateless client needs, like, the transactions need to come with witnesses.
Right. Okay. So then this is actually which is now different from what roadmap that Piper was referring to.
Right. This would be an added piece to the roadmap, is figuring out stateless transaction gossip. It's not, nobody here, I don't think, like, neither of us are saying that it can't be done or that it's like undoable. It's just, it's a significant thing that has to be added.
Right. I mean, I agree. It's difficult, but I also think that we've come to the same conclusion here, that you don't get the benefits of statelessness unless you can do stateless transactions as well.
Right. And this is on the roadmap that I'm kind of proposing we do right now, is stateless transaction gossip. Sorry, Alexei, did that, I agree. We had a blind spot in terms of like really looking at what the end goal produces. Did you have more that you wanted to add to that?
No, it's not like we had a blind spot in terms of the main goal, the end goal. I think we had the kind of end goal, but actually it was more, maybe it was probably my fault, because I was so convinced that we could do this without witnesses attached to transactions. And the reason I thought that, because I wished to, basically, yeah, I think it was my kind of mistake to try to push for this specific approach when the witnesses are generated by miners, because it was very convenient in lots of other ways. But there was this blind spot, which I haven't noticed for a long time. And I think you now picked it up. And so, yeah, I think that's why we're here.
Cool. So like the stateless client that I want lives in this like upper left corner of my graph that I'm just sitting on this screen. This is the part that I'm like, that's the thing that I want. I mean, it's part of like why I started creating a client years ago, because I had this like big, like bright-eyed pipe dream of like just writing a lightweight client, despite that being just fundamentally not reasonable to do on the current protocol. And it took me trying and failing to figure that out. So clients are heavy, and we like want lightweight clients, and stateless clients are like a cool idea for lightweight clients. But the thing is that, well, like I pointed out, the stateless clients that we can make with our current roadmap aren't that interesting to end users, to the use cases that I'm kind of focused on. So like LES hasn't really kind of showed up as the like thing that gives us lightweight clients. I think that the client server architecture doesn't really scale well, and I think we've seen that in the network. I think that there's totally a place for LES, but LES doesn't give us the thing that that we need. LES still just leans
Hi,
on.
sorry.
Yep.
May I? Sorry, I was totally late to the call, and then I'm sorry, I just started echoing and everything. Stupid Zoom just started really slowly, but I just want to say that yeah, I totally agree about like LES not being the most, I don't know, practical solution to our current problems, and I'm totally open to your ideas. And yeah, so okay, go on. Sorry.
Cool. So like, I don't think LES is going to get us there. The client server architecture doesn't scale well. It still just leans heavily on the full nodes. There's kind of a tragedy of the commons problem there.
What does LES stand for?
The Light Ethereum sub protocol. And it really depends heavily on just asking full nodes to do the work for you. So things like providing proofs for account information, things like looking, canonical block indexes and canonical transaction indexes, things like that. So I want something that lives in this upper left corner. This is sort of the idea behind like the stateless client that we wanted. And so I kind of went through a bunch of just thinking about this to see like, what does this look like? And this is kind of the end goal that I want to build, something that runs well on low resource devices, that doesn't actually require any syncing, and you just turn it on and it works, that the networks are designed to scale without a kind of client server imbalance, and then it serves the whole JSON RPC API. I've done a decent bit of work, like really looking at this problem, like looking at what clients do that is computationally expensive, that makes it so that we can't run on low resource devices. These are things like the canonical indexes. I've got a bunch of slides here, but I feel like this is like the raw, like I don't know. I don't want to kind of, I'm not sure this is the right context for me to give this talk, but basically I want stuff that runs on low resource devices like this. We've got history that shows that we can do things that don't sync with heuristics and jumping straight to the head of the chain and backfilling, and there's ways that you can write clients that do this. And making networks that just are fundamentally designed to handle, whether or not it's the 10,000 nodes we have on mainnet today or 1 million light nodes like flooding the network. I can go into details about this, but I think now that I'm like in this, I'm gonna stop this one and look at this document instead, because this really outlines at this group's level what I'm proposing. Here's our current roadmap, which is basically like we need block execution via witnesses. Some level of witnesses coming around, the ability to distribute them. This is sort of like part of our existing roadmap. This is the part that's basically what we're already doing. We need the ability for transaction pool to participate in the transaction pool. So this is like research that needs to be done into designing a new gossip protocol that is conducive for stateless clients without the state to participate in it. And similarly, like we need those clients to have access to some of the other gossip mechanisms as well. We're going to need just general block gossip, and we're going to need to be producing witnesses and gossiping those around in some way as well. But I'd say that the majority of the like added work that we're looking at is also just in the on-demand access to all of the different pieces of history and state that are really necessary to be able to serve the JSON RPC API. So what I am essentially coming to the table with is my intention is to do these things. Not necessarily all myself. My team is focusing on some of these problems. I am looking for other people who want to work full-time on this. This is something that I have no guarantees that I can provide right now, and I'm not going to like go into details talking about funding on this call, but there is funding available for teams who want to work on this. And if you want to do that, then come talk to me, and I will find you the money to work on this if that's the blocker. So I'm not looking to redirect anybody's work that's already working on something. I'm looking for people who want to work on this expanded roadmap, which includes building out what might be 3 whole new networks. It might be 1, it's unclear, but essentially we need to fulfill these like pieces of functionality. And it looks a lot like the actual clients for these networks aren't going to look anything like existing Ethereum clients because they're not going to be part of the ETH Dev P2P network. So we're looking for client teams who are interested, not necessarily existing client teams. If one of them wants to, great, but like I think that we're looking at really fundamentally different looking clients. And if there's a team out there that wants to be first to the table at making one of these, well, I'm looking for those teams who are interested in building this out. Questions? I mean, at a high level, that's it. That's what I'm proposing to do. That's what I'm intending to do. And I wanted to put it in front of everybody to see if there's any blind spots that I'm missing, questions people have, that sort of thing.
I have one question. It was in my mind, and I know Ansgar asked it as well in the chat, which is I just want to make sure that we disentangle the validation. Am I correct in saying, we need to have stateless access to nonces and account balance state in order to do transaction validation for gossiping transactions decentralized throughout the node network. However, full kind of equivalent access like LES, where you can get any state you want as an ultralight client, that's really needed by the end user looking to form a new transaction and wants to understand the intricacies of will their contract actually execute the way that they want when they submit this transaction. And so that's a much more, I guess the reason I'm distinguishing them is that the second one is a really big heavyweight network, I think, and the first one is a much smaller undertaking. Are you looking at doing those two separately, or
I think at this point it's unclear. So state network is like gaining some understanding of what solutions look like that are going to work. Transaction, like stateless transaction gossip, is probably the piece that's been looked at the least. You're correct that nonce and balance are kind of a key part of validating transactions. Transaction, like being part of the transaction pool, is just inherently heavy. Like it's a big job that clients have to do. And so I think part of this research is looking at, can we actually make that lighter weight as well? Can we allow clients to manage a subset of the pool if they want to limit how much resources they're putting towards it?
I think Mika, you've raised your hand.
Yeah, so just to throw a wet blanket on the party here, account abstraction and new transaction types are likely to break the assumption that all you need is the nonce and the balance in order to validate a transaction, because once account abstraction lands, who knows what state you're going to need in order to validate a transaction.
No, that's not entirely true. I mean, you should be able to validate a transaction using the contracts balance. That's kind of the whole point of account abstraction, is that you won't need anything other than the abstracted accounts state. So
I thought the account abstraction version 1 allowed you to read some state.
Yeah, you need a little bit more than just the balance, but the echo is really bad. It makes it really hard to talk. But yeah, you need a little bit more than just the balance, but it should be still pretty minimal.
So sorry, I just one thought I wanted to add to this is that even if we don't have stateless transactions or whatever, it is possible to propagate a proof of the balance and the nonce with the transaction. So that could solve this problem.
Totally, and that's essentially what I've got written down. It's just that it gets a little bit more complicated because you've got things like who's updating these proofs for transactions that sit in the pool for a while, and are there DOS vectors can you make it essentially worse by continually like poking a balance that's trying to pay for a transaction? Or
one question here I have is, do you actually need to update transaction witnesses if you like forward transactions immediately, and later you just keep them in the pool, in your local pool, but you don't re-forward.
Again, this is like I'd rather us not get deep into how stateless transaction gossip works. It's mostly that it just has to get figured out and done for us to be able.
Oh yeah, of course.
To broadcast transactions. So it's just one of these added pieces of work that somebody has to work on, and somebody's got to get it done, and somebody's got to actually build it. So, yeah. Sorry, I'm not trying to like shut down. Well, I am trying to shut down conversation, but hopefully not rudely. The problems are totally tractable, in my opinion. We just need to do them, and they're not currently on the roadmap necessarily. So. So this is, yeah, expanding it to add gossip, state history, or state availability, and chain history.
There's also another angle to this, which I think Rick has mentioned in the chat, although it's not as trivial, is that this whole notion of minor extractable value and a lot of work now being directed into a lot of work and energy being directed in figuring out the what can we do with the transaction pool, because we are pretty quickly getting to the point where transaction pool actually becomes the resource then, which is most likely going to be abused in the future. Like we had these resources, whatever it is, the bandwidth, the storage. Now the transaction pool is likely to become one of those resources, and the reason why it is abused because it's been provided for free by the participant of the network, and there's going to be more and more sophisticated ways of kind of using and abusing it, almost like you see people firing transactions, canceling them, and so forth. Maybe there is the need for kind of thinking a bit deeper into, does this transaction pool model which we have going to survive a very long time, or is it going to force some new stuff that is kind of more reliable? I don't know. Maybe the things that we're hanging on to is actually going to die very soon.
That's my hope. Like the things that I've identified here, like you make a list. It's the canonical chain index is work that clients are doing for free because you can request blocks by number. The canonical transaction index is mostly a user-facing thing, but it's very valuable because everybody wants to look transactions up by their hash, and you need 32 gigs of index space to do it. Transaction pool is a commons problem that, right, like you said, the work is being done by all of the nodes, and it's really heavy work, and it's like you said, maybe prime for abuse. But in general, it's something that isn't scaling super well, and it just requires nodes to throw more and more resources at it as the transaction pool grows, it gets used more, and the chain gets used more. Because identifying each of these resource-intensive things and then looking at the problems to say, how can we turn this into something where the work gets spread out across broad sets of participants that can show up with smaller amounts of resources and handle these problems.
No, what I'm actually getting at is that, I have identified with your help that the transaction pool support was a blind spot for the original kind of pure stateless client design, which actually, yeah, sort of a bit embarrassing, but it did happen. But now I realize that, we actually kind of really like tweaking things to like, okay, so this was the blind spot. What if we tweak it in such a way that it doesn't become a problem anymore? And so my point is that what if there exists some replacement for transaction pool, which kind of makes this idea work again? I mean, I'm not sure that I want this to happen, but when maybe there is such a thing.
I mean, we're talking about the abstract idea of a scalable transaction pool, whether or not it's still the pool as we think about it today or whatever goes forward, or whatever, but it's...
No, what I mean is that it's sort of, I just want to be cautious not to throw too much energy behind these kind of re-implement the transaction pool as we know it in a new way? Because you said that, you know, these things that you want to create are going to be completely different from what we have now.
Mm-hmm.
And I'm just worried that these new things might just replicate some kind of broken design that we have. But yeah, that's all.
Let's just try not to do that, I guess, is the I mean, the other thing that I really like about this approach is that right now it's really hard to iterate on the current like ETH protocol because it holds the network up and we need it to keep doing that. And while it has its problems, it's done that well for us for years now. But it's really hard to iterate on because the barrier to entry is incredibly high to even participate in the protocol. And so I want to break that apart, and I haven't seen a way to do it until now when I just look at it and say, okay, well, maybe we need to just make these separate networks that aren't as utterly mission critical because they don't hold up the core of the network, at least not immediately. And it gives us the freedom of movement to figure out what works at a without as much. Go ahead.
So, sorry, are we removing TX gossip, or is this effort wanting to try to keep it by building a gossip pool?
So we don't like the ETH protocol. Like, I'm not talking about changing the ETH protocol at all. That lands on like existing client teams because they're the ones that are using it. And so this is about there's going to be things that have to bridge between the ETH protocol and whatever other things get built here for a new version of transaction gossip that is conducive to stateless client participation. I'm not saying that we can't do this by changing the ETH protocol. It's just that's very much out of my control. And so it's not a problem space that I can actively work on, at least not easily.
So I think that over time, I mean, I'm pretty involved in MEV Geth. I'm some level of involved in 1559. I just don't see the existing transaction pool as surviving both of those things that are happening, you know, completely disjoint. I mean, between the two of them, the existing transaction pool, I just don't see how that will exist. I think that there is a question around, just from a game theory perspective, there's some basic fundamental issues with how Ethereum is designed in this lack of contract between the miner and the transaction submitter, the end user. And I think that we're running into that problem here. And I'm just going to also point out this problem is related to the global state problem as well. So, shared global state, right? So if each transaction could only interact, you know, established its state and then could only interact with that state, you know, in like a more sane computing model, then you wouldn't have to recompute the transaction proofs, and it would make sense to only provide transactions with proofs, in fact, because that it all sort of be logically consistent.
I can completely agree with all of that. I think that is the direction that I want to take the protocol, that I think that we should be taking the protocol, is towards whatever it is that we can figure out to mitigate some of these just systemic problems that we have. Like you said, global state that any transaction can touch. It makes it inherently difficult to do transaction validation and gossip.
Well, actually, the
gossip network is important to be able to bring back some notion of mempool. Is that right?
Well, basically the reason why we have this issue about the transaction pool connected to the state, why does transaction pool need the state, is not actually that very complex. Is because you simply want to prevent the kind of the multiplication of useless transactions, and the way you do it is just simply check the balance and nonce. So, but instead of, you don't actually need the entire state, you just need the balances and nonces of the things that are sending transactions, which, to be honest, is not such a huge thing. I mean, if we separate, let's say that theoretically, if we separated the state into two parts, one of them is these things that are required by transaction pool and everything else, then of course that thing that required by transaction pool is actually pretty small. And so I think the problem is that we have to bring this whole thing only because we just need that little small thing for the transaction pool. So, but I agree with Rick that perhaps even with this small adjustment, it's still not going to survive for a very long time. We probably could maybe, in order to to make sure that the transaction pool works for stateless, stateless clients, we can make a state adjustment. But then, is it going to last for a very long time? I don't know.
Does anybody else have questions about specifically what I'm proposing we add to the roadmap?
Yes. Okay. Yeah, I turn my video to. No, I turned it off. It's really shitty. My net is slow. So also my hair looks stupid. So what I wanted to ask is, I really like, so you said you just want a gossip network instead of this light client protocol that we currently have, and I really like the sound of that. So actually, I had quite a lot of stuff in mind about improving the topology of LES, and actually the reason the protocol is like still, as I designed it as a first idea that sounded like a good idea, so is because I was lately really focused on problems of incentivization and stuff like that, and I think now I'm getting somewhere with that. But yeah, so I think the topology also really needs to be improved. Yeah, so this is what I wanted to approach from like the side of incentivization. But do you have any specific ideas about like how to improve the topology? Because that's like the key question.
Yes, but they're completely unvalidated. Like I'm working on writing simulations right now for some like different topology, like some, whether or not the things I'm thinking of actually form the topology that I'm hoping that they do, and whether or not gossip still works in that. But the rough idea is trying to basically build the network out such that the emergent property is that the miners are, I just think about them being highly interconnected in the center of the network. They're the ones that care about seeing everything and are willing to put the resources towards it. And then spreading out from there, you get fewer connections heading out, but lots of connections, like essentially of nodes with roughly the same resources that they're putting towards things. So the lowest resource nodes end up the furthest away from the miners. Their transactions take the longest to get there. They're highly interconnected with each other, but they're less connected with the like people who put more resources in. And essentially everything flows kind of in towards that middle part of the network. But it's very abstract, and like I'm working. Yeah.
Mm-hmm. So I think I have like, I think it's like, yeah, it's easy to come to imagine like something, and I so this is basically what I try to like build an incentivization algorithm that could end up like in a similar topology that you described. But maybe if you have like ideas for the other side of it, like how would this thing be formed and everything. So I'm really like
cool. I'll share what I'm
interested in. So let's not discuss it further in this call, but yeah, so let's talk later about this. Okay.
Yeah, I should say that we did pass through the half-hour point, Piper.
Yep. So if there's any last questions, I'm happy to answer them. I'm also happy to talk with people separately, whatever. Speak now. Otherwise, I'd like to hand the floor over, regardless, in the next 3 minutes to Paul for him to do.
So it sounds like, Piper, with your effort, whether there's going to be a, like these mempools in ETH1 or ETH2, right? Your effort's going to help preserve those.
I mean,
is that right?
What I think this leads towards is, assuming I'm assuming we do these things and we do them well and they work, we get ultralight clients that are totally suitable for extremely low resource devices. We build some tools that are useful for existing clients, like being able to drop all of the ancient chain history because we've built a network where you can get it. And that we start, rather than seeing clients exist on the far ends of these spectrums, they slowly start filling in the middle space as well, as people peg themselves somewhere not all the way on the heavy end, not necessarily all the way on the light end, but we have these network tools that clients can use to build out different types of functionality. So I don't know if I actually answered your question, but
I guess if we think it's a problem if clients are just going to connect directly to miners and validators, right, and not have the gossip network anymore.
No, I mean, I think that there's definitely a gossip network that needs to be built for this to work. That we need.
Yeah, that's right. But my question is the other way. That we don't want clients or nodes to just talk directly to miners and validators. We do want a gossip network, right? So that's why this effort itself is building a gossip network. So it is helpful to like prevent these, the direct miner validator communications.
Really, this is not like, there are definitely ETH2 tie-ins here, but this is the only place in which this is related to ETH2 is in the fact that Stateless and ETH2, there's some benefit there in the stateless block validation, and that there's just some similar needs.
Yeah, I guess I bring up ETH2 because there will be the merge, right? So even if the ETH1 mempool like goes away, then there will be a merge, and then so we have to think about
merge. The mempool would exist as it currently exists unless it was modified. So by default, you just kind of get the same mempool in validators instead of miners. Well, and in full nodes and whatever that network looks like.
Right. Okay. So I guess I was just wondering then. Yeah, general thoughts here about, is the mempool, if it does go away, right? Because that's what MEV Geth.
I don't think we're talking about getting rid of the mempool.
No, we're not. But let's say MEV Geth gets more and more adoption, so that there's less and less transactions. Let's say 0 goes through the mempool, right?
We have a very big problem if that's the case, because we're no longer censorship resistant.
Yeah.
Because you now have
I don't
centralized.
I'm not following where this is going, but like I don't think anybody here is talking about getting rid of the mempool at all.
There's chatter in the chat about MEV getting rid of the mempool,
I mean,
and I don't think a lot of people here know what that means.
Yeah, I'm the person saying that. So yeah, so basically, because of miner extractable value and sort of the incentive misalignment that creates, and again, because of the way the transactions are constructed and the way that global state is constructed, what's happening is traders, who are our largest users, want to have quote unquote private transactions. And the way that they are achieving this in the immediate term is they're sending the transactions directly to the miners and they're bypassing gossip. So that's Spark Pool Tai Chi, which works this way. There's another tool that is very popular called MEV Geth that allows it's sort of complicated because it's attempting to be altruistic, which is very difficult. So the narrative is a little jumbled. But basically what you do with MEV Geth is you send a bundle of transactions. You send an anchor transaction, which is the transaction that you want your bundle to be applied before or after. And you send that directly to miners.
So this is totally like parallel and orthogonal to what I'm talking about doing. Like having private transaction pool stuff is absolutely something that people can do, but we still need a public, some concept of a at least for some time here, of a public gossip network.
So I think the problem,
these two things can both exist, and like so I'm not sure, like I'm not sure what.
So I think that I'm just going to go through the sort of the logic here, my reasoning, expand on it a little bit. So if we're just focusing on traders transacting directly with miners as opposed to using the pool, I mean, again, remember the vast majority, at least 90% of the transactions are done by traders. So our transaction volume is going to drop, significantly, and I think that ultimately, we're just. I agree that what I'm trying to say is that we never actually really had, I guess, sort of from a philosophical position, although we created a permissionless gossip network, the incentives were never really there for that network to scale. The way the system has been designed, the existing public gossip, it quote unquote works as long as, all the transactions are worth the same. It works as long as there's these certain game theory constraints.
I don't think that there's if you're I'm not sure that we have anything that needs to be discussed here, because I'm not saying that we can't have a private transaction network. I get that there's flaws in the public gossip transaction network, but we still need it for at least some time here. So
yeah, I guess what I'm suggesting is that we do need to keep the existing network, but I also think that from a design perspective, where we're kind of slicing along the wrong axis, right? There's some core problems to Ethereum, and we see those core problems emerge in a whole set of different places. And so if we attack at the, at the bottom of the tree, if we're looking at the consequences and not the roots of the problem, then we're kind of, it's inefficient, right? Because we're not really going to solve the problem.
So I don't think that we have any argument here. This can be part of the research into what transaction gossip looks like. Let's talk about that more, because the idea of how we do transaction gossip for stateless clients it's a totally open-ended problem right now.
Yeah, I mean,
and I'm rushing us off of this because I do want to give Paul the floor to talk about his piece before we run out of time. So
yeah,
so let's go down that road and explore what fundamentally different transaction gossip models might look like. I'm just proposing we need to have some people working on this, so let's do that.
Yeah, and I just want to ground it a little bit more of just being a protocol. The goal here, I think, Piper, when we've talked, is that the protocol design has implications for the resources that a client has to bring to the network to be a successful participant.
Yes.
And somebody, one of these rules of nature is that if state has to be stored, someone has to be storing it. And if you ask a question, someone has to answer it. And so part of the protocol design is figuring out one that as people come into the network and ask questions and ask for state, they also naturally become participants in holding some shards of state and answering some fraction of the questions as well, so that the network on its own gets more powerful as more people join it and more requests and more state needs to be added to it. So that's really the protocol design. Is a lot of it is around the protocol that allows a group of successful light clients who just are bringing with them relatively modest CPUs and memory footprints and bandwidths to create a network that has the kind of capability of serving state of some of these centralized ones that are in the bottom left of Piper's diagram. So just wanted to ground it in terms of this isn't just an abstract protocol thing. It's about a protocol that leads to the right kind of clients that are naturally form the right kind of network.
Adding more computers should add capacity, not the other way around, is basically what you're saying.
Correct.
Yes. Sorry if I said it the reverse way.
No, not at all.
And since my name is Robert and I'm running Robert's Rules of Order at the moment, I will adhere to Piper's request here. And even though I spoke last, I apologize. I'm going to cut it there. And let's move it over to Paul so he can talk about regenesis, which at this point, we've been thinking about this quite a bit in our brains. So this will be a very natural flow into Paul's discussion. So Paul, you've got the floor. Paul, you might be muted or I can't hear you. Oh, there you go. Yep, I can hear you now.
can people see what I'm showing? It says
Yep, we see Regenesis design goals.
Okay, so this is just a LibreOffice. It's easier for me, like this. So Regenesis design goals. So this conversation was great, and thank you for the introduction. Nice introduction, Robert. That I think there are these sort of discussions that have to happen, but I sort of want to maybe steer it towards something written. But the thing is that I'm realizing that things are changing. You know, every month or two, something else comes up. We have some new idea. We have new things. So this isn't final. So what I'm trying to present here isn't final. It's just sort of a snapshot of my sort of current understanding of it. And maybe other people will give me some help understanding, and maybe other people will benefit from this as well. So just to get through it quickly, I really like this problem statement from I think maybe Alexei wrote it. And I hope everyone, if there's something blocking something, please let me know. The problem statement, I'll read it quickly. Preserve resilience of Ethereum 1 network despite the stake growth. So we already identified that there's a stake growth problem here. And that there's a resilience problem with F1. By making it easier to join the network, we're already talking about syncing and stay on it. So resources, things like this, and therefore increasing the number and diversity. So we're already talking about security. So this is a really nice sentence. The improvement to user experience is not in the scope of what we're doing. So we're doing core protocol stuff, not user experience stuff. So this is sort of, an engineering problem. We have a problem statement. We sort of have maybe design, criteria for success, things like this. But things are changing. Design goals have come in over the years. This is the major one. I think this is a critical one that is often overlooked. That Martin said, we don't want caching in consensus. So Alexei had his moving window cache. He solved the problem with caching with his Medium posts in 2019, like February and March and April 2019. But then Martin said in early 2020, no caching in consensus. This is just so complex. Then we need extra caches on top of it, extra journals, extra all of this. And we're already, struggling to have enough cache. So we have to design it in a way that we don't have this sort of cache and I think this can be done. We have this sort of infrastructure of blocks. So maybe they're attached. We're like stacking these blocks. I think Geth calls it stacking sort of diffs. So we can maybe put this sort of regenesis data and this active state in these sort of diffs that we stack, and we accumulate them with time. So my point is, we can't have this sort of pool, this sort of cache. Martin's going to push back. We want to keep everyone happy. That's the thing. And if we have this sort of huge complexity, sure, it solves the problem at a high level, but when it comes time to implement it, you have all of these extra secondary caches and things like this. So this is a big sort of design goal, design request, no consensus cache. And I'll just go through a few more. And the thing is, you have to sort of follow it as we go along. So we have canonical witnesses. We're requested a few times. I found it requested once here in the Regenesis announcement. We talk about Merkle rules. We want 32 byte hashes, two 32-byte hashes to go to a 32-byte hash for Merkle trees. But the question of Merkle trees is still, we want to be accumulator agnostic. But that's just, these rules are sort of coming in as you go along. You're sort of a detective and you're just accumulating these sort of things. I proposed an access list witness correspondence. Now access lists are first class objects. And now witnesses are going to be first class objects in the whole protocol. These are just, high priority. It would be nice if we had a sort of link between them. It sort of makes a lot of things nicer. So I'm just going through these sort of things that you accumulate if you read along. Another one, Danny said, this isn't a requirement, but we would like to have stateless block if we want to leave the option open for stateless block proposal. So stateless mining. We don't want to. Let me restate this. It's not a requirement, but we don't want to make it to sort of make design decisions that make it impossible. So we would like to keep this option open. So you go along, you collect some sort of design goals, and I wrote a few of them. I would like to grow this list. We don't have much time, but just a few of them I already touched on. I'll explain them again. No consensus cache. Clients can use, internally, caches, journals, shadow stacks, Bloom filters, these kinds of things to solve their own problems. But we don't want the consensus to have some sort of this sort of complexity. But since we have no consensus cache, how are we supposed to store regenesis? Well, maybe, inside of this sort of block stacking, we have the blockchain. So inside of these blocks, and that's what if you read the Geth snapshot blog post from July of last year on the Ethereum blog, they explain that this is exactly how they do it. So I think we can fit this. This is a major thing that to satisfy no consensus cache, but I think we can sort of get around it by embedding this sort of cache inside of the blocks. And another one is forward looking to Eth2. The regenesis period. I say regenesis. What I mean by regenesis is sort of like a generalization of all of these things. Fully stateless. Regenesis is sort of like a good abstraction level that we can sort of later on say, okay, shrink the regenesis period to even to 0 or to 1, whatever. So we evict every block. Finality is coming. That's gonna improve things. And Danny's post that I just scrolled by, leave options open. For example, state execution and shards. Not a top priority, but let's not close the door yet. Stateless block proposal. The accumulator. There's already talk about replacing the accumulator. So our design should be, Merkle tree should be swapped in and out, should be swappable. And let's not intertwine the design and leak everything across, the Merkle stuff is leaked into everything else. Especially this is going to be interesting when we design the active and inactive state. Let that be the first class, the active and inactive state, and then the Merkle is just some design detail of that, but fully contained under the sort of heading. This is active state. This is inactive state. For now, we want a binary tree with this Merkleization rule that we just saw. Witness dependence is minimized, so that was my proposal: is accessless witness correspondence. So we have a witness. I give you an access list. You should be able to give me a witness that is independent of the block execution. That is independent of but it's an access list dependent on it's an access list and an active state and an inactive state. You give me these 3 things, and I can give you a witness, and we can all agree that it's canonical, minimal, these kind of things. And another design goal that was mentioned a few times. I'm just accumulating. I'm just sort of picking up things as I go along. Regenesis event is critical, so we have to be careful with forks. There are options with this. I want to add to this list. I want advice on how I should do it. I know this isn't a fixed list. I know things change as we go along. Things become more important. But I'm going to open the floor for feedback now.
It's a good looking list. There's some interplay between figuring out what the cold state mechanism is, because right now there's kind of, unless you just go through and do execution, I think that's one of the areas of research that needs to be figured out, is how we actually denote what state is cold and what isn't.
Are you talking about active and inactive state? By cold, do you mean inactive state?
Yes, it's basically like something's inactive if it's, well, in the regenesis event, if it's before the regenesis event. But there's some concept of like knowing which things were active or inactive, and
yes.
There's an alternate route to that, which is actually having a mechanism that says these things, which I guess is really like rolling regenesis, is if we can just continually drop things that are colder than 1,000 blocks or 1,000,000 blocks or whatever, then we're effectively in rolling regenesis, which is, I don't know, it's just a different mechanism of it. But I
wouldn't call it regenesis. I wouldn't call it regenesis anymore, Piper. It's like
you're right. It's not regenesis. It sounds like a cache. It's something else.
It sounds like a cache.
Sure. Yeah, it's treating the active state as an LRU cache.
Yeah, but then that violates the no consensus cache. We would have to get around that somehow. And I think with regenesis, it's cleaner to do. Regenesis solves so many problems simultaneously, so that's why I'm speaking about it. That's why we sort of pivoted away from this moving window LRU cache to this regenesis events. But these regenesis events bring some sort of criticality at the forks that we have to discuss things like this. Anything else, please? And also meta sort of, how do I accumulate more of these sort of points? I know it's a changing list. and I want to share it with people. I want people to discuss it. If this is effective, it's possible that what I'm doing is ineffective, and I should stop, but maybe I should just keep it to myself, but please give feedback.
I want to give some feedback. So first of all, in general, I really appreciate that you keep looking into this, because there might be. I just wanted to explain a little bit. Like, there might be an impression that I kind of gave up on those things, but I didn't. I don't actively research the regenesis at this moment. I still think it might be possible to do. What I'm trying to do at the moment is actually to create more tools for the further work, because I just realized I can't. I mean, I'm not the person who can do research without the tools, and I don't think we have them at hand. So yeah, so I just wanted to say thank you very much for doing that, and you're very meticulous with collecting the collecting the history and the doing things, and I know that you're also quite good at coding, because I saw what you did with the EVM 384. But yeah, so I'm really glad that you're doing this, and I wanted to let everybody know that I haven't given up on this, but I'm just coming back for more tools.
Okay, so this is, we're over time. Alexei, thanks for letting us know. That's, I hope we can sort of get you back to thinking about the regenesis again, because you're sort of a driver and we need you to drive it. Or, well, maybe someone else will have to do it, but thanks for giving a signal. We're over time, and Robert or anyone else want to start?
Could I ask one thing real quick? For the adjustable regenesis period, it'd be nice if someone documented what the pros and cons, like there's a contention here where if you get too short a regenesis period, you have one set of problems, and if you have too long a regenesis period, you have a different set of problems. It'd be nice if those were documented, so we can try to think about, what is figuring out what the ideal regenesis period is. There's probably a sweet spot somewhere in the middle.
So Danny Ryan said 1 day is the shuffling and 1 day look ahead. That's what he said last call, and that's quoted. It's a bit in a bigger part of this quote. I agree with you that it's qualitatively different to have a very short one and a very long one, and we can design differently for long one and short one. And yes, I agree with you that it would be good to know what the qualitative differences are, and how we can maybe find a happy middle ground between those, and maybe be generic enough so that we can pivot to. The problem is we start designing in one direction. That these are fixed parameters, these are fixed constraints, and then as the constraints change, we have to sort of pivot. And when things are in consensus, we sort of are left with these design warts, which I hope that we can be forward-looking enough. Of course, it's not fully avoidable, but I'm hoping that we can sort of identify these things and think things and be forward-looking in the design. Thank you.
Okay, I think we'll, anybody else want to jump in if they have a question, but otherwise I think we'll wrap up the discussion for today here. Hopefully it was helpful for people to have a little bit more of two targeted kind of discussions this time. I think we had kind of agreed that we would have some more topical discussions that are opt-in between, but otherwise we'll keep the monthly meetings going. Did anybody want to have a little bit of discussion about if there's a topic that somebody wanted to brainstorm a little bit that we wanted to do on another call?
I have a minor desire to talk more about a middle ground. I've discussed with Piper a bit on this. Piper's a big fan of kind of a more homogeneous network where everybody can participate equally. Whereas I feel like there is an opportunity where we can get a bunch of the stateless benefits, or at least some of the stateless benefits, with a more heterogeneous network where you have nodes like Infura and Alchemy who exist within the network, and they're just doing more work, and for whatever reason they're doing it for free, but they're doing it for free right now, and they don't seem to be stopping. And so I think we can leverage that and get some benefits of stateless for cheap, or for much less work than trying to do the full everybody's a light client sort of thing. I would like to, at some point, talk about that more. Don't worry, though.
I agree. It'd be interesting to talk about other network models too, like where not every node is equal. Like some could be hubs and super hubs, like the old Nutella networks, would be an interesting kind of approach as well. So
Sam, that's exactly what we're doing. I've talked about Vulcanized DB on this call in the past, and we're still working towards that end. Yeah, so we actually are taking that exact approach where we have gateway nodes, that effectively bridge between dev P2P and then our own WebRTC based protocol.
Okay.
Yeah, I guess one thing I should say is my understanding of any of these networks where you have light clients that have a protocol that allows them to both leech as well as seed state and request handling on them, they all will end up like what you have, Rick, or what we saw with Mustakala in the KitsuNet approach previously, which Piper has referenced in his, previous historical kind of work that he's, incorporating ideas from. They'll always end up having some aspect of a heavier node that looks like a bridge or a gateway that takes the kind of state from dead P2P and then refactors it in a way that is able to be sharded and distributed in the distributed hash table of the light client network. Who is sharing the screen right now? Somebody has. Okay, good. There's a little card there for GitHub. So I think there's going to be. I think Mika, I'm glad you raised that point. That I think today's discussion, Piper, was trying to shift and refocus a little bit more on this issue around the transaction gossiping and the kind of ingress side of the statelessness versus a lot of times when people look at statelessness, there's this very big value, of course, on the validation side. And us having a network topology kind of discussion, I think that's a good topical discussion as well. So we'll put that on the calendar. Thank you.
And we generally have channels in the R&D Discord for each of these things. I post a lot of updates with what we're doing. That's a great place for us to continue conversations.
Okay, great. Yeah, like Piper's saying, please do, if you don't actively kind of look at those, or if you're not on those, please do go on them. There are good discussions going on there. And thank you everybody for coming. Very helpful discussion, and have a great rest of the week, everybody.
Thanks, everyone.
Thank you all.
Thanks all. Bye.
Thanks, everyone.